last time was standard normal, right? Standard normal distribution. A lot of the time, vast majority of the time, you're not dealing with a distribution that has a mean of 0 and a deviation of 1. So a lot of times we're just working with normal distributions. We can treat any normal distribution as a standard normal, right? We standardize it. This is the z-scores. When we're going to calculate by hand or using the table, that's what we're going to have to do with any normal distribution. We're going to have to standardize it. When we're using technology, we don't worry about it. Again, we'll do a mix of those. So remember, standardizing, you're going to make use of z-scores, x minus u over sigma. Right, well, all z-score does, remember, is tell you how many standard deviations away from the mean it is. What does a positive z-score represent? So if the z-score is positive, what does it mean? Z-score is positive, let's say positive 1. What does that mean?
Because z-score is positive, the value of 1 is the value is above the mean.
I mean, you're over the mean, right? So a z-score of 1 would mean you're how much over the mean? It's actually on screen too. Z-score measures how many standard deviations away from the mean you are, right? Z-score of positive 1 is 1 standard deviation above the mean, right? Negative z-score would mean you're below the mean, right? So negative 1 would be 1 standard deviation below the mean. Right, and then again, if you're just given a regular normal distribution and you're only allowed to do it by hand, you would have to convert your x value into a z-score, and then table B would be used. We can convert backwards as well. So we can go from a z value to an x score, because this is also going to be used sometimes. Right? And that is, x would just be mu plus z times sigma. Again, mu is the mean, sigma is your standard deviation. X normally distributed, find the following. For this one, I will write out what our mean is. And what the standard deviation is. Mean 62, standard deviation is 7.5. This we are going to do by hand. Start with that. Probability that x is less than 70 is the same as the probability that z is less than. So z is the standard normal random variable. Less than 70 minus 62 over 7.5, right? So we're converting 70 into a z-square. That's what the 70 minus 62 over 7.5 is. So 70 minus 62 is 8 over 7.5. I'm going to go to 2 decimal places. I got 1.07 for the z-score. Make sure you can get that. Let's give them everything else except for the blood table. So we're less than 1.07. Remember what the table gives? it gives area less than, right? Oh, good, so we don't have to do any kind of funky math. We can just read it right from the table. We are looking for 1.07. So there's 1.0. Now we need to go to the 7. It's this one here, isn't it? So that's our probability. 0.8577. Probability that x is greater than 50. So we again standardize. Z is greater than our z-score or 50, right? The standard value of 50. What is that? Negative 1.60. But the table gives area less than, right? This is greater than. Remember what we did. If you wanted an area greater than from the table, what do we have to do? Subtract what? One minus what? What about into the negative 1.60? Which number? Not the negative 1.60. It's going to relate to that.
The whole time, like the value after
What value?
the area negative 160 or the
Right, area, what area relates to negative 1.60?
I don't really know how to put it into words, but the less than, let's see.
Technically less than or equal to, but it doesn't distinguish that. Area to the left of the negative 1.60, right? Because that value is in the table. negative 1.60. Oh, look, it's strong. Yay. It highlights. I click the one, unfortunately. I can write on this, it won't save it. That area right there, right? 0.0548. Zero point 9452. Standardize. And so we found the z-scores for 58 and 66. And then what we're looking for is the area that is between them. What do you get for 58 as the z-score? 9.53. And what is it for 66? 0.53?
Yeah.
If we're looking for area between two values, what did we do? Because again, the table doesn't give us that area. It only gives us area to the left. So what did we have to do? If I remember correctly, it was you who told me what you said let's do. So what did we do?
I didn't take good notes.
No, that's a problem.
So you, because it's symmetrical, right? And you're able to. Can't subtract.
You are subtracting. Well, in this case, but this is coincidence. Which one?
Find the negative value. Or
Positive.
Positive value.
The larger one, remember?
Oh,
That gave you an entire area, and then the smaller is like this little bit here.
yeah.
So we need to find this area first and subtract from it this area. But wait a minute. That's less than. That's not going to help. Yes. Oh. I'd like to find one value, because as you mentioned, it is symmetrical.
Yeah, I remember you said something.
Those two areas are identical.
Yeah.
So it doesn't matter, you could do less than the 0.53 and subtract the less than negative 0.53, or it's just 1 minus twice this probability. Due to symmetry. So it's negative 0.53. Let's come down, negative 0.5. 1, 2, or 0, 1, 2, 3. And why can't you see my cursor? Should have that enabled. That cursor shows up, right? Yeah. So why does that one show up, but not my pen cursor? Capture cursor. Okay, so I don't know what's going on. I'm not looking for that. But that would be our area, right? 0.2981. When you do that, you should get 0.4038. Right, because that's going to be what? Twice 2981 is 5962.
What we got, like, with Kim and Ham? Or two,
Hmm?
like, things from breaks, like,
Well, technically, I don't have that we're closed almost the entire week. My other school doesn't close until Thursday. So I work actually right until Wednesday. No, I need like a year off. I need to take sabbatical. This one is. Weights of a certain object normally distributed, mean of 180 grams, standard deviation of 24 grams. Find the 90th percentile and the middle 80% of weights. Remember, 90th percentile. We're going to start with standard. Is that value of little z that makes that probability true, right? 90th percentile is the value in which 90% of the data is less than. So we have to go over to the z table. We're going to look for area 0.9000. It's somewhere between those two values. It's going to be kind of equally spaced, isn't it? No, it's not. What am I doing? Actually, more. It's closer to that 1.28 than it is to the 1.29. I'm just going to use 1. My notes have 1.2816. But again, that's probably using calculus to find the exact value. That's what I'm going to use. I actually do not want to go lower, I don't think, because that wouldn't really be the 90th percentile. Be slightly less than 90th percentile. Going too large, though, is also a problem. So I'm going to split the difference. I'm just going to go right in the middle. 1.285 is what I'll use for this. I would let you use 1.285 if I was asking you to do it by hand. Just comment that that's why I'm using 1.285, because it's between 1.28 and 1.29. But that is just the z-score. We want actual weight. Well, that is mean plus z-score times standard deviation. Mean was 180 grams, right? There's our z-score and our standard deviation of 24 grams. I got 210.84. That's the 90th percentile. So it's like about 210.84 grams. Next one, they want the middle 80% of weights. Middle 80%. Right, if we draw this out, that's what we're looking for, right? The X1 and X2, where that middle point is 80%. But then what does that mean each tail is? Y10. Right. Right, so it's 0.20 you need. Why is it 0.10 in each one? Because of the symmetry, yeah. And because it's symmetry, I'm just going to need to find one Z. Because then that'll tell me that the other Z is just the opposite sign of it. And then we'll convert to the regular values. So what we're going to want to find first is the Z value that gives that probability. Which we know is going to be up here somewhere. And we actually did this last time, I believe. It's going to be somewhere between there, but it was really, really, really close to that negative 1.28. So that's what I'm going to use. I'm just going to use the negative 1.28, which is the same value as the other one. Which is 98%. So the lower bound for that middle 80%, the mean minus 1.28 times the standard deviation. Got 149.28. The upper limit for that middle 80%. Same thing except it's plus instead of minus. Oh, that should give us around 210.84. I'm sure to do that calculation to see how different it is. To 10.72 is what I got by using 1.28 instead of 1.285. So the middle 80% of the weight is going to be between the 149.28 grams and 210.72 grams. Next two examples is going to be using the calculator. So we have a random variable normally distributed with mean of 95, standard deviation of 11. We want to find that probability. This. Up. There we go. And so remember it was menu, statistics, Distributions, normal, CDF. Now again, this is for my calculator. You have to find where your distributions are in your calculator. They gave us a lower bound, right? It was between 90 and 112. But what's the mean? Mean was 95, right? And the standard deviation was 11. There's the probability. Same Y. Find the cutoff value for the top 10%. Well, if we're looking for the top 10%, what are we looking for? What is it?
Top, so like the top 10%, like the highest.
Yeah, what is that? What else does that mean? Highest 10% means it's the,
90th percentile.
we're looking for the 90th percentile. Statistics, distributions. Now we want the inverse normal. For the inverse, you need to enter area to the left, which is the 0.90, 90th percentile. The mean, 95, the standard deviation, 11, enter. 109 point whatever. That is standard normal, so yeah, let's work with that a little bit. So this is going to be all done in Excel now. Let's quickly take a look at what they're asking. Standard normal, find first probability that Z is less than or equal to 1.33. Equal norm dot distribution. X value 1.33. Mean is 0. standard deviation is 1, true. This will give area to the left of 1.33, which is another 1, right? (97.5th percentile). Then what is the area to the left that we are looking at? We're looking at the 97.5 percentile. Looking for the z-score that has what area to the left of it? What is it? Right, less than. So area less than is what? If you're looking at the table, what would you be looking at? What area to find the z-score? What area did we use here?
Then,
0 point what?
97.
You can't have two decimal places.
Sorry, 97.
Yeah, 0.9750, right? So this is norm. I could be using the standard, I'm just going to use the regular one. Norm.inv for the inverse norm. Probability we're looking at, 0.975. A mean of 0, standard deviation of 1. And there's your z-score. Now for a non-standard. What is the mean for this distribution? is our mean? So come back up to here. How did I determine the mean? See it? What's the mean? 68, right? What's the standard deviation? 9.5. We want probability of x being less than or equal to 60.
Isn't it supposed to be a comma?
Oh. You can see that. Yeah. There we go. You really want to get confused? I think, is it Europe? I think Europe uses commas instead of decimals in their dollars. So 68 comma 95 means $68, whatever their dollar is, and 95 cents. They might even use commas to separate the thousands. So it'd be really confusing. So less than or equal to 60. Let's come over here. Norm dot distribution. X is 60. We said the mean was what, 68? And the standard deviation was what, 9.5? And it is cumulative, so true. Nice if I use the right limiter. There's the probability. Now greater than or equal to 83. I believe there were two ways we could do this. The easiest way is probably going to be to use complements. Let's see something more. I don't know, it doesn't give me an interval option, does it? What it did. Doesn't matter, I'm not going to use that anyway. It's going to be 1 minus the normal distribution. We were looking for greater than or equal to 83, right? So it's going to be 83. The mean. Standard deviation. True. Which is not what's in here, so I'm assuming that's wrong. Yeah, okay, so my notes must be wrong. That's okay. And the 25th percentile. That's going to be the inverse norm, right? Norm dot inverse. What is the left area we're looking for if it's the 25th percentile? So 25th percentile is area to the left equal to what? What does the 25th percentile mean?
Highest of a quarter of the values.
That's technically correct, yes. What is a quarter equal to?
25%.
Which is what?
Or like 25% of 100%.
Which is what as a decimal?
Oh, 1/4.
As a decimal. That's
Oh,
a fraction.
0.25.
So 0.25 area to the left, right? Now we just need the mean and the standard deviation. Close it out. And there's the value.
It would have to put rate.
Hmm?
The formula doesn't have just by the end.
The formula? You got it? I can't zoom in out of that text box. So it's, again, just more of what we were doing on Tuesday, just an extra step, right? In our distinct process. Unless we're plugging into technology. When it comes to taking the test, are you going to be required to use it? Maybe. How can I tell if you used one? Obviously, if you give me more decimal place than the table gives you, I'm going to know. But you're going to be allowed to use your calculator. So, this is going to be a really nice test, isn't it? Because a lot of it's going to be done right on the calculator. And we really don't calculate this stuff by hand in the field anyway. generally speaking, we're just writing the code to do it all for us. We just put that and go, okay, here's what I want to do, code it, boom. So get comfortable with both calculator and reading the table, but mostly the calculator. That also unfortunately means there's not a lot of chance for partial credit. If you're just putting to a calculator and giving me what it gives you, how do I know what you put in the calculator? So it's a double-edged sword, right? It's easier because it's all calculated, but no chance for partial credit. So it's all or nothing.
I gotta get that, yeah.